My name is Sophia Flynn, and I created this application, RSA Decryption Methods, using Python programming software and one of Python's built-in tools, tkinter, to create my graphical user interface. The focal purpose of this application is to calculate the value of the decryption key D in RSA encryption using two classically time-consuming methods involving semi-prime factorization and logarithms, and from there, the app can calculate the amount of iterations that are required to calculate the decryption key using either method, thereby indicating the efficacy of either technique in different circumstances. This app was really designed for a more scientific audience who has background in encryption, but can also be used by novices who are interested in learning more about decryption methods in RSA encryption. So I'll launch my app now. This is the graphical user interface that pops up when I first launch my app. Either of these two buttons will link to YouTube videos that I created to help users of my program learn more about the RSA encryption algorithm in general, and learn specifically about the different decryption techniques in RSA encryption. So in this first part, the user is asked to input a semi-prime number input. So if I enter in an input of 143, which is a semi-prime number, and a secret positive integer message that I'd like to encrypt, say 24, and click Store My Inputs, these are both acceptable values according to my program, so the program prints that this is indeed an acceptable semi-prime input and an acceptable message input. So once those two messages pop up, the program then prints this next part of the screen, calculating D. So for the first method, the program calculates D via semi-prime factorization, first factoring n, and then going through the steps necessary to calculate D from there. And in the second step, to calculate D by logarithms, the program calculates the decryption key directly, but in this case, because of the numbers that I inputted, 143 and 24, D takes more than 1 million iterations to calculate. So in this final part of the program calculates exactly how many iterations it takes to calculate D using either method. So through semi-prime factorization, it takes 141 iterations, whereas through this logarithmic technique, it takes almost more iterations than Python can handle. So in this case, decryption through semi-prime factorization is obviously the more efficient technique to calculate the decryption key by looking at the number of iterations needed to calculate D using either method.